Here we are at our example 2 from our 4.2 set of notes. We're asked to graph this following quadratic in vertex form. And right away we just noticed that our a value is -2. Our h value, notice how it says x plus 4. Our h value there would actually be -4. And then our k value is +1. Okay? And so the reason why identifying those values is useful is right away then you have your vertex, which is h comma k. And so our h value again is -4. Our k value there is 1. Again, from the previous video, we just talked about how you just take the opposite of the value that's inside the parenthesis, and then your k value you just take just as it is. So going ahead and plotting our vertex, we end up with our coordinate -4, 1. So that would be right there. And then our axis of symmetry is super similar to before. It's just x equals -4. So then, again, that acts as our mirror going up and down. X equals -4. Now for our y-intercept, we're going to go ahead and plug in 0 for y. I'm sorry, 0 for x, and then figure out what is our y. And so just cleaning this up a little bit, we have y equals -2 times 0 plus 4 squared plus 1. So then y equals -2 times 0 plus 4 is 4 squared plus 1. That'll come out to be 16. Plus 1. So then we get y equals -32 plus 1. And as a result, we end up with y equals -31. Now, that you can end up with, and I wanted to talk about this example where when you see that situation, when you get these extreme y-intercepts like that, it is on the graph. However, what you might want to start to do is start to scale your graph, okay? And because you kind of want it to try and squeeze on there. So for x's, we'll still continue by 1s. Our x values are not really being impacted too much, so by 1s. But our y values, we can go ahead and scale by some other value. Maybe we'll choose by 5s. Okay. So when that happens, what you do have to do is go back to your vertex and scale that appropriately. So our value -4, 1, notice how on the graph it looks like it's at -4, 1. We're then going to have to change that so that it looks more on this correct scale with the y values of 5, being scaled by 5. So -4, 1, if each one of these is 5, then your value, your coordinate for the vertex would actually be closer to kind of that x-axis. So that would be more of what your vertex would look like. Okay. And now we can go ahead and squeeze on this y-intercept, 0, -31. So then we would have to go a little bit beyond 6 in order to get to that -31. So 0, -5, -10, and so on. 15, 20, 25, 30. 31 is just below that value. Okay. Now, for the reflection point. Since that is 4 units to the right of the mirror, our axis of symmetry, we would have to go 4 units to the left of the mirror and place our little coordinate there. And so that coordinate, what that comes out to be, is actually at -8, -31. Now let's go ahead and choose a value, some other point that's really close to our vertex. So maybe we'll choose like -3 or, yeah, we'll just go with -3. That'll come out clean. But you could choose a lot of other ones. You could choose like -2, -1. You could even choose like -5, but we'll just go with -3 for right now. So again, we're going to plug in -3. This is our choice. You get to plug that in. So y equals -2 times -3 plus 4 And again, the reason why we choose those other points is it helps us with the general shape of this graph. So you just have more coordinates to be able to like show your curve a little bit better. According to GEMDAS, we got to do our parentheses first, so that's positive 1 squared plus 1. 1 squared just comes out to be regular 1. So then negative 2 times 1 plus 1. Negative 2 times 1 gives us negative 2. So then we get a y value there of 1. No, negative 1. So negative 3, we got a y value of negative 1. So in the graph, what that would look like is at negative 3, negative 1 is just below that. So then when we reflect that, we would have it at negative 5, negative 1. Again, since it was 1 unit to the right of the mirror, you'd have to go 1 unit to the left of the mirror. So that's how we obtain that reflection point. And now we can go ahead and create the general shape of our graph. And when we do that, we would see a shape that does something like this. And so more or less that would be your parabola. Now for our domain, again, that's not really changing with parabolas, negative infinity to positive infinity. For the range, we read that from bottom to top. So our smallest y value there is negative infinity. Our highest point that it ever reaches is at our maximum. And in that case, that would be at normal 1 from the vertex. And you can't ever obtain infinity or negative infinity, so we know we obviously have a parenthesis around that because 1 is at your vertex. You can't obtain that, so that's why he has a bracket. Again, though, the main point of this example, though, guys, is to scale your graph appropriately when you have to, and your scales can differ based upon whichever axis you're on, so they don't always have to be the same. But again, though, that is example 2 from our 4.2 set of notes.